So let's start. So let's talk about spanning tree protocol. So we have spanning tree protocol. Spanning tree protocol. Now, what is this? This is basically used for stopping loops in a closed fashion. In a closed fashion topology. When we say it is in a closed fashion topology, it is something like that. If we are connecting the switches back to back, something like this even, so there is a loop. Why? Because of the broadcasting nature of the switch, right? In case we are connecting the switch in a closed fashion, again there is a loop. Why? Because again it is an enclosed session. So to prevent it, one of the port goes blocked, one of the port goes blocked, so that the free flow of the data should be there, right? And this can be, and every VLAN has its own spanning tree instance. So that's what is IEEE 802.1d. The standard is IEEE 802.1d. Now, what are the few terms in the spanning tree? We have root bridge, who's elected as the boss. Root bridge as a boss. So all ports of root bridge are forwarding. Forwarding means technically the term is that they are designated ports. DP, designated ports. And they send the traffic. They send traffic towards non-root bridges. Non-root bridges. So one thing, root bridge, right? How it is elected? It is elected based on the lowest priority, which is 32768 plus VLAN ID. And I told you every VLAN has its own spanning tree instance. So the priority is a tie factor. So the election goes on the lowest MAC ID, right? Or bridge ID. Either you say it is a MAC ID or a bridge ID, it's same. So root bridge. Root bridge is elected as a boss who's having the lowest MAC ID in case, and the priority can vary from 0 till 65535, right? You can vary. And the priority is always in multiples of 4096. So either it is 0, 4096. So like the multiples of this. So if you set the priority as 0, that particular switch will be elected as the root bridge and nobody can defeat it. Second election is the root ports. Root ports. So the ports, they are also forwarding ports. And they have the lowest cost to reach the root bridge. Lowest cost to reach root bridge. Now when you say cost is nothing but the bandwidth. For 100 Mbps, the cost of the port is 19. For 1 Gbps, the cost of the port is 4. For 10 Gbps, the cost of the port is 2. And so on, right? And they are also forwarding ports. So basically, if you will see it, they are the directly connected ports to the root bridge. designated ports. On 4 conditions, the designated ports are elected. First, lowest cost to reach root bridge. Second, lowest MAC ID. Third, lowest port priority. And lowest port number. Lowest MAC ID and lowest port number. So first this condition is matched. In case if it is same, then this. In case if it is again same switch, then this, which is by default 128, and the lowest port number. You can take the screenshot. In case any doubts, please come back. Take the screenshot. In case any doubts, please come back. All good till here? Igor, Kalyan, Nistala, Mohan, all good till here? Srikant?
Yes, ma'am.
Good.
Yes, ma'am.
So reply me now. If you have taken the screenshots and all. I have switch 1 whose MAC is A. I have switch 2 whose MAC is B. I have switch 3 whose MAC is C and C. They are connected directly with 100 Mbps links. 100 Mbps. I told you this link will never have any bandwidth. The bandwidth is always of the port, right? So when I'm writing 100 Mbps, actually the ports of the switches are 100 Mbps, right? Now the port cost is 19. Every port cost is 19. And the port number is F0/1, F0/2, F0/1, F0/2, F0/1, F0/2, right? Now the loop will be formed. Do you agree the loop will be formed? And some port has to be goes blocked. Here the STP is now an inbuilt protocol of the switch. Similarly, alpha bridges switches, the switches are switches. They are also having the inbuilt STP protocol which is working. Right? Now, which switch do you think will elect as the root bridge? Priority is by default 32768 plus VLAN ID 1. Why? Because only VLAN number 1 is working. 32769, which is same for all the switches. So who's having the lowest MAC ID? A, B or C? Which one is having the lowest MAC ID?
Yeah.
A, very good. So this will become root bridge. And what is the condition I wrote for the root bridge? If you see, you can take the screenshot. All ports are forwarding.
Forward.
So all ports are forwarding. So this becomes DP, this becomes DP, and they send the traffic towards the non-root bridges. Now, root port. If you will see it, root port, what are the conditions for the root port? Lowest cost to reach root bridge. So let's see lowest cost. This port is having cost of 19 to route the root bridge. This port is having 19 plus 19 to reach the root bridge. That means 19 plus 19 is 38. Why? Because it will include its port cost and then this port cost. So cost is 19 from here. And the cost to reach the root bridge is 19 plus 19, 38 from here. Do you agree, everyone?
Yes, ma'am.
So which port will become a root port? This port and this port. And they send the traffic towards the root bridge. So they are also forwarding. Now I am left with this port and this port. So I asked you to take the screenshot for the designated port. So first condition is lowest cost to reach the root bridge. For both it is same, 38 and 38. Do you agree?
Yes, ma'am.
Next point. Refer to the screenshot. Next point. This was a tie. Lowest MAC ID. Which is having the lowest MAC ID? This one or this one? B, not C. It's hexadecimal. B. Yes. So this will become DP and this will go block. Do you get it? Do you get it?
Yes, ma'am.
So the traffic of VLAN 1, right now I have only VLAN 1. Whatever belongs is belonging to the VLAN 1. In case if I have even the different VLANs, always the traffic flow is like this. It will never use this link. And this whole process to detect which port is the root bridge, which port goes into the root port, which port is DP, which are NDP, that means non-designated ports or blocking ports. This whole process takes 50 seconds to decide. So the convergence time for the STP, I don't know whether you have noticed that whenever you are connecting a PC to a switch, it takes some time. It takes this port to go green. It takes approximately a minute, 50 seconds to go green. You can even observe this time. Whenever you are connecting the PC to the switch, it takes some time to go green. Whenever you were configuring some trunks, it is taking some time to go from the down to upstate because of STP. Irrespective whether it is connected in a closed loop fashion or not, every time STP is run on all the ports of the switches. Got it? Got it? So somewhere you will see 52 seconds. This 2 seconds is nothing but the hello time. Hello. To check everything is okay. So if I'm receiving hellos from you, I can see yes, you are also okay. If you are receiving hellos from me, you can detect I'm okay. But in case if I'm not going to receive any hello for 20 seconds, I'm going to declare you as dead. Let's say I'm not going to receive any hello from this switch 1. So what this switch will think that this link might get faulty. Something went wrong here. So it will try to open up this link after 50 seconds just to allow the free flow of the traffic. Isn't it or not? Tell me. Got it? I have switch 1, I have switch 2, I have switch 3. And they are connected like this. For after 50 seconds with a STP, I got to know that this port is blocked. After every 2 seconds, they send hello. This also sends hello. This also sends hello. This also sends hello. This sends hello. This sends hello. Everyone is sending hello, hello. But what happened due to something which this switch has started misfunctioning or something has happened. I don't know what has happened. It has stopped receiving the BPDUs. It has stopped receiving hellos. This switch 2 has stopped receiving hellos. So what will happen? STP will think that this link is no more. So I have to open up the blocked port. So it will open up it after 50 seconds. It will make it to the DP and all the traffic will continuously flow like this. Do you get it?
Yes, ma'am.
Right? So technically these hellos in switching world is known as BPDUs. and they are exchanged after every 2 seconds, and BPDUs are known as bridge protocol data units. Bridge protocol data units. Fine. Now do one thing. Okay. Before this, I have already asked you to draw a topology. I don't know whether, yeah, I think maximum of you people have drawn it, and you have made one switch as VTP server, and these ports are all trunk, right? You can see there's a trunk. One of the port goes blocked, right? You can make this as VTP client, right? You draw this topology, please. Make the domain name as abc.com, right? And once it is done, once you have made the trunks and all, everything is done. What you do, you add VLAN 10 and 20 and 30 here. This should get reflected here and here, and then you check with a show spanning tree, right? This thing, please do it and let me check, and then display the screen. Any one of you who's done first can display your screen, and I will guide you what is PVST, per VLAN spanning tree. This is per VLAN spanning tree. What is the need of this? Now this is open standard. Now what is the need for this? Understand. Right now, if I have multiple VLANs, let's say this is VLAN number 1, this is 10, this is 20, this PC is 30. This PC is VLAN 1, this PC is 10, this PC is 20, this PC is 30. Let's say what happens that this port goes off. I mean, because of STP, this port is blocked. Now, how the traffic will flow? Like this. But right now, because these are all 100 Mbps ports, right? There is a lot of congestion. STP will never take care of congestion. Until or unless this link goes down or this switch is faulty, then only it is going to open up its port. Otherwise, whatever it may be, whatever is the delay time, jitter time, lost time is coming, these switches will never take care of it. STP will say, until or unless the link is up, I am good. I don't have to change the topology, no matter what a congestion level is there. What kind of whosoever might be the delay is there. Right? So for that, we always segregate the traffic by saying that we have to configure per VLAN spanning tree. Why? Because when you will configure this, and let's say some of the switch will become root bridge for all the VLANs, and it will become root bridge for all the VLANs. I don't want that particular switch to be a root bridge for all the VLANs, because there is no segregation, no diversion of the traffic. So in that case, what I will do, the switch which is having the blocked port, I will make this switch as the root bridge for certain VLANs, let's say 20 and 30. And in that case, this port will be blocked for 1 and 10, let it be. But for 20 and 30, I think this port goes blocked. So as a result of which, what will happen? 1 and 10 will keep on flowing like this, but 20 and 30 will keep on flowing like this. Do you get it? Do you understand what I'm trying to say? No?
No, ma'am.
No, no problem. Do one thing, take 3 switches, configure a VTP server, configure a domain name, configure the VLANs 10, 20 and 30. This you can do. Configure the trunk ports. This you can do.
Yes, ma'am.
Do it. And share me the screen after you are done and check with the show spanning tree. ये करो और मुझे फिर check करो. So what you have to do? You have to take 3 switches, 1, 2, 3, connect them back to back, configure this as VTP server, VTP client, VTP client, configure these ports as trunk, domain name please configure as abc.com, and add VLAN 10, 20 and 30 in the server, right? Once you are done, then check show spanning tree command and tell me which is the root bridge. And please observe the output of the spanning tree. Fine? Go ahead. If you have any doubts, please come back. कोई doubts हैं तो पूछो. Take the screenshot. Then we will observe the show spanning tree. This total process in the show spanning tree output you will see 52 seconds. Why? Because 2 seconds are the hellos which every switch is sent to each other, and these are the hellos of STP. Hellos of STP. Please come. And you will check that for VLAN number 1, 10, 20 and 30, the same switch will acting as the root bridge, and the port which is blocked for all the VLANs. This is the output you have to show me, right? Configure it and show this output. And then I will tell you the logic of PVST. And then I will again discuss what is RSTP, MSTP and all. So that once you will configure it, then only you will understand it. What is it? Otherwise, you will not be able to understand RSTP and MSTP. How much time more?
I completed it.
Share your screen. This is Tagore or Murli Krishna?
Yes, ma'am. Ma'am, my screen visible, ma'am.
This is Tagore, right?
Yes, ma'am.
Fine. Good. Very good. Yes, it's visible. Very good. So your switch 0 is the blocked port, right? So your switch. So show me the root bridge. Maximize करो इसको. Tagore, maximize it. Maximize the screen, Tagore. Good.
Yes, ma'am.
So this is the root bridge, right?
Yes, ma'am.
Good. So for VLAN 1, this bridge is the root. Both the ports are forwarding.
Yes, ma'am.
Port cost is 19.
Yes, ma'am. Both of.
Very good. Port priority is 128. For VLAN 10, same as the root bridge. You can highlight. Please.
Yes, ma'am.
You can highlight. Good. Including VLAN 10. Everyone, please focus here. Leave your work, right? So for VLAN 20, highlight for VLAN 20. This bridge is the root. Yes, very good. For VLAN 20 also. Good. Including. Start from VLAN 20, like you have highlighted 10. Okay. For VLAN 30. Go down, Murli. Select for VLAN 30. Everyone, anyone has problem here? Murli Krishna, Mohan, Navya, Nistala, Mukesh. Tagore, go down for VLAN 30. Tagore, go down. Press enter. It's having some internet connectivity problem, I think. Anyone else who's done?
Madam, I am done, ma'am.
Okay, this is Murli Krishna. Share your
Yes,
screen.
ma'am.
And please highlight the root bridge who shows spanning tree.
Okay, ma'am.
Who's this? Sadhanala Vara. Who's this? Rajkumar. Okay, Rajkumar is also done. Good, Rajkumar. So please highlight for VLAN 1, this bridge is the root. Please increase the font size. Go to the packet tracer. Go to the packet tracer. Go to your packet tracer topology. Topology. Nothing is visible, Murli Krishna. Go to your PKT file, the lab diagram.
Ma'am.
Good. Go to the options on the top. File edit options. File edit options. Good. Preferences. Good. Go to the font. Good. CLI font 17. 17. Good. Apply. Apply. Good. Go to the interface. Go again to the options files. Go again to the options files, options preferences. Good. Always show port labels. No. Interface here. Always show port labels. Checkbox that. Good. Very good. Close it. Close the window. Good. Now please open the display screen of the switch which is acting as a root bridge. Show spanning tree. Enlarge karo. Good. Now show spanning tree. And you can please highlight all the VLANs. For VLAN 1, this bridge is the root. Start from the VLAN 1. Highlight VLAN 1. Good. For VLAN 10, this bridge is the root. You can highlight VLAN 10 as well. You can highlight VLAN 10 as well. Right? For VLAN 20, this bridge is the root. For VLAN 30, this bridge is the root. Got it? Enter. Now read the output of the spanning tree. What can you see? Hello time is 2 seconds. Highlight it. Hello time 2 seconds. Hello time 2 seconds. Maximum age 20 seconds. Which is a dead timer. Maximum age means if I don't receive any hello from my neighbor switch for 20 seconds, I will declare it as a dead. And forward delay is 15 seconds. What is forward delay? Forward delay is the time where I will take the decision in deciding that okay, this port has to be into the forwarding mode and this port has to be into the blocking mode. So there is a forward delay timer. Ideally here it is 15 seconds, otherwise it is 30 seconds. So here it is written 15 but by default it is 30 seconds, right? So you can even add it up. Add kar sakte ho aap. You can add it up. 30 plus 20 plus 2, which makes 52 seconds. Do you get it? Forward delay is listening, learning, then forwarding. That means the time it takes to decide, okay, this port is forwarding and this port has to be into the forwarding mode and this port has to be into the blocked port. So right now it is written 15 seconds, but it is 30 seconds. 15, there is one more stage which is 15. So 30 plus 20 plus 2. How much? 52. Do you get it? Everyone. This is a question for everyone. Any doubts, any problems? Someone?
No, ma'am.
That means the now show me the blocked port. Show me the switch which is having a blocked port. Show me the switch which has a blocked port. Open it up, show spanning tree. And you will see for all the VLAN, the port is blocked. You can highlight it for VLAN 1, for VLAN 10, 20, 30. For all VLANs, it is blocked. So this port, this link is unutilized. Do you get it or not? Anyone has any doubts? Come back. Anyone has any doubts? Come back. All set, all clear? Till here?
Yes, ma'am.
Good. So what we will do, we will make this switch as the root bridge for certain VLANs so that the ports should be open. There is, see, there is one port which is permanently blocked for all the VLANs. What I want a layer 2 diversification. Something like you are 10 people. And for all of you 10 people, let's say you are 10 people, Murli Krishna, Mohan, Tagore, Mukesh, Navya, Nistala, Rajkumar, Kalyan, you want to go to a particular destination, and for all of you there is a one port, one door which is permanently blocked. But the door from which you are going through is facing a lot of congestion because you are 10 people. So definitely your speed of going is slow, right? But what I will do, I will ask, okay, I have two doors, and for half of you, this door is still open, but for half of you, the other door I'm making open. That means I'm making root bridge, the same root bridge for the existing VLANs, some of the VLANs, but for some other VLANs, I'll make some another switch as the root bridge. Do you get it? I'm doing load balancing. I'm saying that half of the people should go via one door, that is via the root bridge, which is still existing. And for half of the people, make some another switch as the root bridge so that some other port will go blocked. And this switch whose port is blocked will become open because now he is declaring itself as a root bridge for certain VLANs. Do you get it?
Yes, ma'am.
Good. So go this switch port is blocked. So go to the configuration mode. Go to the configuration mode. No, CLI. CONF, configure terminal. CONF, configure. Write down CONF. Murli Krishna, get into the configuration mode of S2. How do you get it? CONF, configure terminal.
Ma'am, there is an issue with my laptop, so it is not displaying anything when I'm typing, ma'am.
Oh. Okay. Who else can share his screen then? Rajkumar, you share your screen. Rajkumar, options में जाओ. Go to options. Preferences. Font. 17. CLI font is 17. Apply. Close the box. Go to the switch whose port is blocked for all the VLANs.
I made 6 1 as block.
Okay, no problem. Enlarge it. Maximize the screen. Good. Go to enable. Configuration mode. Good. Very good. Enter. What we are doing for all the VLANs, this port is permanently blocked. So I'm opening this port for certain VLANs. How can I do this? I cannot say you please open up and the port will start listening to me. What I will do, because STP is making the ports open by declaring the switch as a root bridge. So for the root bridge, all the ports of the root bridge are open. So I am making for certain VLANs this switch as a root bridge so that it can open up all its ports. But some other port will go blocked for VLAN 20 and 30. Do you get it? This port is still blocked for 1 and 10. But for 20 and 30, I'm announcing this switch should act as a root bridge so that all the ports of this switch should be open up for 20 and 30. But since STP is by default working, some other port will go blocked for STP for the VLAN number 20 and 30. But this port will always be blocked for 1 and 10. How do I do this? In this concept is known as per VLAN spanning tree. So go to write down spanning tree. Press tab. Good. Spanning tree. Press tab. You have to press tab while writing down the spanning tree. Yes. Good. Spanning tree. VLAN 20, 30. Space. Priority. Put question mark. Put question mark. What I am doing? Space question mark. So what it says that the priorities are in the increments of 4096. So what I'm doing, I can say that priority is 0 or priority is 4096 or priority is 4096 into 2, whatever the value comes. And it goes till 61440 because 61440 is a multiple of 4096. So you can write down priority 0, whatever you want to give, 4096 or 0. Enter. Enter. Good. Control Z, come out of it. Now check show spanning tree. This is known as per VLAN spanning tree, layer 2 load balancing. So for VLAN 1, this port is still blocked. Highlight. Highlight it. For VLAN 10, this port is still blocked. Go down. Enter. 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 Enter, enter, enter. Yes. Highlight VLAN. Wait. Scroll up. For VLAN 10, this port is still blocked. Wait. Highlight karo. For VLAN 10, this port is still blocked. Everyone got it till here? Tagore?
Yes, ma'am, got it.
Murli?
Yes, madam.
Good. Go down. For VLAN 20, this because I have reduced the priority for which VLANs 20 and 30. So he is declaring himself as a root bridge. Can you see VLAN 20? This bridge is the root. Highlight it. 20 and 30 for both. 20 for VLAN 20 as well. Yes. And both the ports are designated. That means it has opened up its port for VLAN 20 and 30. But some another port is getting blocked for VLAN 20 and 30. Can you check down? Can you check in the topology which switch port is blocked for VLAN 20 and 30? And you can see all the ports are green now. Can you see this? No bandwidth is blocked. No passage is blocked. And there is a free flow of the traffic whenever I want. Like say half of the VLANs you go via earlier path, and for half of the VLANs I'm making some blocked path as a available path, but some another port will go block. So you can check show spanning tree on other switches and it will show you that show spanning tree some port is blocked for 20 and 30. Check it. I'll just wait. So yes, tell me what you have observed. What you have observed while seeing this? That there are two ports which are blocked for VLAN 20 and 30. Which port? Which ports are blocked for VLAN 20 and 30? Show me the other switch. The other switch. See, this bridge is the root. Enter. No, this is designated and root. Show me on some another switch. Client 0 or whatever it is. Show spanning tree. No, not this. The other switch. Because this bridge is already the root for 20 and 30. So you don't have to check time and again on this. This is already a root bridge, so it has all the ports opened for 20 and 30. Some another switch is there which is there for the blocked for 20 and 30. Third switch, which switch is left now? And maximize it. Show spanning tree. Enable. Show spanning tree. So VLAN 1, okay, fine, the ports are open. VLAN 10, the ports are open, designated and root, they are forwarding. For 20, VLAN 20, enter. For VLAN 20, see, the port number 2 is blocked. Can you see? Highlight karo. Right? Earlier it was open, now it is blocked. Why? Because you are load balancing the traffic. You are making one link as a primary link for 1 and 10, and you are making other link as the primary link for 20 and 30. Any doubts here?
No, ma'am.
Good. So this concept is known as per VLAN spanning tree. So what is happening right now? This port is blocked for VLAN 1 and 10, right? And this is the root bridge. Let's assume what I'm doing for right now, this is blocked for 1, 10, 20 and 30, all VLANs. But what I'm doing, I'm making this switch as primary root bridge for VLAN 20 and 30. So what will happen? Some another port will go blocked. Let's say this port goes blocked. So what will happen? This for VLAN 1 and 10, right? For VLAN 1 and 10, this is the primary path, right? And for VLAN 20 and 30, for VLAN 20 and 30, this is the primary path. For VLAN 20 and 30, the traffic will go like this. Do you get it? This is
For one doubt.
what? Come again?
One doubt, ma'am. There we have for status we have seen like forward block and some LSN is there, ma'am. What is the LSN?
LSN is the listening state. Actually, there are 5 states of the STP. First state is disable, listening, learning, forwarding, and blocked. Right? So disable is nothing is listen. So this is LSN, listening. This is LRN, learning. This is forwarding. This is blocked. Got it? So this whole procedure takes 50 seconds. From listening to learning, it is 15 seconds. From learning to forwarding, it is 15 seconds. So this is known as forward delay timer, which is 30 seconds total. Got it?
Yes, ma'am.
So these are the STP conversion state. Very good question, whosoever has asked it. Very nice. Because if you won't ask me the things, I will not be able to tell you the things. If you will not ask me the things, I will never come up with all these things. So the next is RSTP, Rapid Spanning Tree Protocol, and this is IEEE 802.1W. Now, what is rapid spanning tree? Since the whole process of STP takes 50 seconds or 52 seconds, RSTP takes only 30 seconds to decide which port is blocked and which port is forwarding. That is rapid spanning tree protocol. It has only 3 states: discard, learning, and forwarding. Discard, learning, and forwarding. So basically these 3 states as of 30 seconds. 30 seconds. So the 30 seconds is for the RSTP. And this is again an open standard protocol. This is again an open standard protocol. Everything is open standard. Even STP is open. Open standard means either it is Cisco switch or Huawei switch or Alpha Bridge switch. Everyone obeys it. This is open standard. This is rapid spanning tree, and it is inbuilt into certain switches now. Whereas if you will see the older switches of the Cisco, you will see that you have to enable it, right? But there are a lot of companies which has RSTP by default enabled. So we have to check for the Alpha Bridge switch what is enabled. So RSTP is completely compatible with STP, and this takes 30 seconds to diagnose which port is to be the blocked, which port is to be the forwarding, and that's how it's named, RSTP. And it works on the same phenomena. One switch will elect as a root bridge, another switch will become the root ports. Then there are a lot of other things like designated ports, blocked ports. Everything is same. It's unlike you think that there is nothing which is same. So everything is same. So it is completely compatible with STP. So the switches, even if you are configuring, let's say you have 3 switches. By default your STP works. By default, you know STP works. But if you want that, okay, on one switch I'm enabling RSTP, and if you have forgot to enable RSTP on 2 and 3, what will happen? They are completely compatible. STP works. But if all the 3s are being configured with RSTP, then the rapid spanning tree protocol works. So what is the main advantage I got here is that the reduced convergence time. When it was taking 50 seconds, now it is taking only 30 seconds to diagnose. Fine, everyone?
Yes, ma'am.
Now multiple spanning tree protocol. Multiple spanning tree protocol. What is it? Its name is MSTP. MSTP. And it is IEEE 802.1S. So please check the standards whether it is S or W. I might be forgetting, but you can check it on the Google. But what is the main advantage of the MSTP? What is MSTP? Is basically, if you have seen, when I'm saying show spanning tree, what is happening? For VLAN 1, you are getting a spanning tree instance. For VLAN 10, you are getting spanning tree instance. For VLAN 20, for VLAN 30, that means if you have 50 VLANs in your network, you can see their spanning tree table size is becoming very large, isn't it or not, everyone?
Yes, ma'am.
I don't want this.
Yes, ma'am.
I don't want this. I don't want to see this. I say, please show me very small size of the spanning tree. So what it will do, let's say for these 2 VLANs, switch 1 is acting as a root bridge, right? What it will do, it will map it to the instance number 0. And some other switch is acting as a root bridge. What it will do, it will map it to instance number 1. Right? So instance 0 and instance 1. So whenever you say show spanning tree or show MSTP, it will show you show MSTP, multiple spanning tree. What it will do, it will show only instances. So to the instances, there are multiple VLANs mapped. So it will stop showing you for each and every VLAN. What it will do, it will start showcasing you the instance number. So okay, for this instance number, these are the number of the VLANs, and for this instance 0, this is the root bridge. So I don't get a very long table, I get an instance table. But if you don't have the multiple root bridges, you have a single root bridge, and let's say in my topology, I have switch 1, I have switch 2, I have switch 3. And what was happening that these three switches are connected. And let's say this was blocked and this was root bridge. And let's say MSTP is working. But whenever you are enabling MSTP, it has to be enabled on all the switches. Otherwise, it will give you incompatibility issues. Unlike RSTP, where you are enabling RSTP on one and you are forgetting to enable the RSTP on the other two switches. So MSTP has to be enabled on all the, otherwise it will give you incompatibility issues. So let's say I have 1, 10, 20, 30. These are the number of the VLANs I have. And for every VLAN, this is the root bridge. So whenever you say show spanning tree or show MST, right, what it will give you, it will directly give you these as by default map to instance number 0. Instead of giving the long table, it will only give you the output of instance 0, where switch 1 is acting as a root bridge. You get it? So the spanning tree table size is short. It's instance 0 and that's it. That's all. Do you get it?
Yes, ma'am.
So this is all about your RSTP, MSTP, STP, PVST plus. Any doubts you have, you can ask now.
Which criteria it will follow to 0 or 1? Criteria it will follow.
What? Come again?
On what basis it will like classify instance 0 or instance 1, ma'am?
See, MSTP is a protocol. So by default, it has been designed in such a way that I am going to cover multiple spanning tree protocol within one instance by default. So it will ask you certain things like you give me configuration, name. So what it says, it asks you certain things, and then by default, it maps all the VLANs to instance number 0 until or unless you are not creating any instance, or you are not configuring, or you are not mapping the VLANs to a particular instance. So it is a way of detecting the loop, but at the same time, STP is working. It is blocking a particular port, but at the same time, it is mapping multiple number of the VLANs to a particular instance. So to squeeze down the size of the spanning tree protocol table, and that's it. That's the role of MSTP, and that's it. If you have 50 VLANs, it will not show you all VLAN 1, 10, 20, 30, 40, 50, 2, 3, 4, 5. It can be multiple VLANs in your environment. So what it will do, it will by default map all those VLANs to instance. So you might see only 3 instances or 2 instances, and that's it. And the way of the working is exactly same. At the back end, STP works. Got it?
Yes, ma'am. Yes, ma'am. Clear.
Clear है? ठीक है. So this was all about STP, RSTP, MSTP, and your alpha bridge which supports it, right? And that's it. How to enable it? MSTP we cannot configure in the packet tracer, but RSTP if you want to see, we can enable it. Configuration mode, spanning tree, mode. Can you see this rapid PVST? So this is a command line to enable RSTP, rapid PVST. So rapid PVST, I'll get into, this is switch 0, I'll get into switch 1. I can enable configuration mode, spanning tree, mode, rapid PVST. I can get into the other switch, I can get into the CLI, I can enable configuration, spanning tree, rapid mode, rapid PVST. So it takes around some time to diagnose. Okay, this port is still blocked. So I don't know whether you have noticed or not, this port was blocked with STP and it is still blocked with RSTP. The only thing is the convergence is very fast. So let's see, show spanning tree again. It will give you show spanning tree. Show spanning tree. It will give you spanning tree enabled protocol is RSTP. This bridge is the root. Both the ports are forwarding. Hello time and all it is same, but ideally the convergence time is 30 seconds, right? So you can check on all the switches. The same thing comes up. Spanning tree protocol is RSTP. You can see in this switch, this is a blocked port. Show spanning tree. Same thing, spanning tree enabled protocol is RSTP. Fine. All good? I cannot enable MSTP here because the packet tracer doesn't support it. But we will configure it in the real-time alpha bridge switch. So this is all for today, guys. Next topic, what we are going to discuss in our last class of the switching is ether channel and layer 3 redundancy protocols. Redundancy protocols. This will include HSRP, VRRP, GLP. This is the last class, and then let's see what we'll do, right? What you will do in the assignment, take 3 switches, switch 1, switch 2, switch 3. For create VLAN 1 PC, connect here, VLAN 10, VLAN 20, 1, 10, 20, right? You will observe blocked port with a show spanning tree. VLAN 1 has 60 hosts sitting. Let me write down here. VLAN 1 has 60 hosts. So you can give 2 valid IPs to one PC here and another PC here. VLAN 10 has 30 hosts. VLAN 20 has 20 hosts. And what is the range? Is 192.168.10.0/24. Fine. One 192.168.10.0/24. So what you have to do subnetting, design this, and out of the valid pools, whatever you are designing, take 2 valid IPs, assign it to this PC, take 2 valid IPs, assign it to this PC, 2 valid IPs here and here. They should ping each other and check with the help of the show spanning tree which switch is the root bridge. Do you get it, everyone? You can define.
Yes, ma'am.
Right. You can define the VTP as you feel like with the same command abc.com domain, right? So fine. So let's wind up for today. We are done for today. Any doubts you have, you can ask. I hope STP is clear with a lot of people. Any doubts? Come back. So I'm uploading it on the portal. Right, you can have a look where I'm uploading. So what is this? Gmail, right? Okay. This classroom. And here we not the link. Upload. Till then, any doubts you have, come back. Everyone. Configure RETP domain abc.com and the respective switch which acts like a root bridge as VTP server. So you see which switch act like as a root bridge, configure as a VTP server. Rest of the switches configure as VTP clients. Domain name is xyz.com. Design and submit and IP 92.168.10.0/24 in such a way that VLAN 1 has 60 hosts, VLAN 10 has 30 hosts, and VLAN 20 has, how many I have given you? 30 hosts or 20 hosts?
20, ma'am.
20 hosts. Intra VLAN communication should work. Not inter VLAN, intra VLAN, right? So that's it. Enjoy your weekend. Yes, yeah.
Once it the command for Parvig and STP, ma'am. PVSTP.
Okay. Should I write down?
Yes, ma'am.
As I have written in my white paper document, but what I'll do, I will, whatever I have assigned, where is it? Where can I find it? This one, right?
Yes, ma'am.
Okay. Can I write it here? Edit. Okay, fine. Intra VLAN should work. Configure the switch which has a blocked port for all VLANs make that switch as a root bridge for VLAN 20 by issuing the command spanning tree VLAN 20 priority. Fine.
Yes, ma'am.
But it should be in the configuration mode. Switch configuration. This is hash. This is hash and this is deleted. Fine.
Yes, ma'am. Okay, ma'am.
You can even enable RSTP. Let me write down. Please also check with RSTP by issuing the commands in all switches. Switch configuration mode. Spanning tree mode or rapid PVST. Fine. Fine.
Yes, ma'am. Okay, ma'am.
ठीक है. Chalo, let's find up with a meeting then. Fine. Okay. Have a good weekend. Bye bye.